you can't even taste caramel in it. Is it even a macchiato?
Yeah.
Really?
Sugar-free vanilla.
You can taste the shots. All right, so we have some good news. Make sure this is the newest version. Let me refresh this. All right, so we were doing something a little stupid. Sort of, kind of okay-ish. All right, so let's run this real quick, and then I'll walk through what it is currently doing. So I'll compile the server. We'll come here and we'll compile the client. Line 33. I made a couple changes at the end. Okay, we are connected. I'm just going to do that. All right, so server's running, client connects, client receives hello. All right, so now let me walk through and tell you how that all worked out. And I'm going to say something that's very difficult to say, and I blame this on Haxton a little bit because he quickly agreed with me. But Haxton was right.
It's on recording. It's on recording.
All right. Remember the other day when he said, shouldn't you be passing that sock FD instead of the server FD? And I said no, and then he just said okay. He like thought about it for a second. Totally right. So, and actually this was total amateur hour. This is not as bad as Spieth on 12, but bad. So we want to think about the nature of how functions in C work. And this is, let me go back here. So good lesson, but amateur hour level stuff. And of course, as always, I was testing you and you all failed, especially Haxton, but you know, is what it is, I suppose. So nature of C function calls. All right, so we have to kind of roll back a little bit and think that C, not being an object-oriented language, you had to think about how a language like this would have been built prior to the whole object-oriented mindset in terms of how functions worked. Okay, this and our major hint here goes back to right here, how main returns an integer as a common practice in POSIX C programs. Because generally speaking, when we make a call to a program, which in our world right now may as well be these function calls, I'll talk more about that here in a second, we're expecting some sort of return value, some sort of error code or something like that, letting us know how it went. Okay, did everything happen the way it was supposed to go, or what are the 4,000 different integers it'll return that map to error messages? You know, error 1 means this, error 2 means this, error 3 means this. So that's the common cadence of a C program. And keep in mind, in a Unix operating system, POSIX compatible operating system, the difference between a Unix or a C program and a function call, there really isn't a difference. Those are the same things. When we're making a call to, for instance, right here, the connect function, This is a program that was written, okay, that takes some arguments. It's wrapped inside of the function wrapper, but it takes some arguments and ultimately spits out a result. Okay? So when we're making POSIX level system calls like this, they act more like command line system calls than they do like generic functions. So having said that, what we had here before, I've replaced it with error, which is just an integer. We had server sock, or server FD, whatever it was. We had something like server FD with the understanding, I'll just type it in here, server FD, something like that, with the assumption that the result of connect was to receive the file descriptor for the open socket that is now connected to the server. Not the case. So when we were trying to receive our message from an error message instead of from an actual socket file descriptor, that's why it just kept failing over and over and over again. This guy is a return code. It's an integer that represents what happened. If the error is less than 0, that represents some sort of error message, something bad happened. Otherwise, we're connected, and we're going to go and do stuff. So now let's think about, if we walk through this code up here, think about all the things that are kind of occurring. So this is all setup stuff for our socket. Then we actually create our socket. So we can think about this in terms of our modern programming as a socket object. But back then, it's using universal I/O, so this is a file descriptor that happens to be linked to this socket that's an object-like thing that's a socket on the system. Now, at this point in time, though, this socket has not it's like a phone that's sitting there. It's capable, it has phone lines, but there isn't an active connection. That doesn't happen until right here. So the socket exists right here. Here's our handler, or here's our handle to talk to that socket, our file descriptor. Now, right here, when we call the connect function, the very first parameter to this is our file descriptor for that socket. It's using that guy, and it actually activates that socket. So that socket now becomes a live connection if everything goes well. So we're saying, here's the socket over which I want you to connect. Here is the configuration information about that socket. That's our sock address thing up here. And here's the size of that guy. Go ahead and establish a connection over that socket. Okay? Make a phone call, so to speak. When we get past this line, the return value of connect has nothing to do with the socket other than telling us what went down. It is sock FD whose nature has changed since that function call. Before the connect call, sock FD was an inactive socket. After this function call, sock FD, same file descriptor, but points to now an activated socket, a socket that has a maintained connection. That makes sense? So from that point forward, we're checking the error message here saying, did everything go swimmingly? If so, we're going to come down here, otherwise we'll scream and bail out. But if everything's going okay, we'll go ahead and print out, we are connected. Now we want to go ahead and receive something from the server. So this is just a 2,000 byte char array, if you will. We talked about malloc some last time, and we were chasing down our memory issues. Then we're going to go ahead and get the this is the size of that server. Actually, I don't know if I'm using that anymore. I am not using that anymore. That was the something from before. I'll go ahead and take that out. So this is the message I'll use. This is the string, if you will, I'll use for receiving my result up to 2,000 bytes. Now I'll use my receive call. Now there's various receive functions we can use. We can do receive, which is standard. It's effectively a wrapper for read, but it has some built-in socket flags that we might want to use. I was messing around with some of them because initially I thought receive was not blocking, but this does block. So here's receive. We're receiving over, before I had server FD in there, i.e. try to receive over our error message integer. And the reason why we weren't getting compile errors is because a file descriptor is just an int. It's nothing more than that. It just happens to map at the operating system level to what we hope is some sort of active connection to a file or an active connection to a socket, whatever it is, or to a pipe. Well, we were passing in effectively just a random integer that in most cases happened to be a negative number. Actually, in this case, I think it happened to be a 0 because we were successfully connecting. So it was coming back with a 0. And it just so happened that we didn't have a file descriptor in the system equal to 0, so it had nothing to read over. So it was immediately failing because we were trying to read from a non-existent file descriptor. But imagine, this goes back to kind of the history of some of these older languages, imagine how difficult that bug would have been to chase down if it just so happened. Let's just say that when we tried to connect up here, this used to be called server FD when I was misidentifying it. So just imagine back in the day, well, imagine the situation where we were erroneously storing it as the file descriptor for our connected server, and let's say it returns some number other than 0. Something happened during the connect. And let's just say that that number happened to correspond to a file descriptor in the operating system that happened to actually be connected to something. Now all of a sudden we're not getting failed reads, we're just reading from a different socket or reading from a different pipe or a file, whatever it is, and getting just arbitrary output with really no way to chase it down. So that would have been kind of funny, I suppose, in the end. But in any case, I was using the error value returned from, well, the status value, let's say, returned from connect as the file descriptor for my socket, which is why receive was failing every single time.
Does C9 support breakpoints or no?
Does who?
Cloud 9 support breakpoints?
I think it might have a built-in debugger, but I don't know if it works for C.
Okay.
It would be nice, but I don't think their C program, I don't think run works for C programs. I thought somebody corrected me on that and said it did.
Yeah, like I used Run before. And I'm pretty sure Run does, but I don't know how to set breakpoints.
Well, if run does, so you're saying I should be able to run this? It says listening, okay. And then I should also be able to run this as running in a different, okay, so it received. Okay, well with that in mind then, if that works, we should be able to, you know, basically this guy now knows how to, here I'm going to try something here. I'm going to try to run the server again and see if it creates a whole new window or just keeps it in the same ones. Oh good, that's nice. So I can close that terminal there. We can just use this for man pages and stuff, and we can run our programs here just by hitting the run button. So with that in mind, we should be able to use their debugger. Let's see. Let's see if we can just inspect the, oh, I'm on the, close this for a second. Add breakpoint right here to error. I guess run this. So I gotta stop there. Probably have to run it through the debugger. Tools. All right, well, let me set a breakpoint, but how can I stop Let's just do Cloud9 debug run. We probably have to start it differently than running in debugging code.
Scroll back up at the top. I think it listed what languages the debugger works for.
Where?
You can also, oh no, it's just executing the application.
Let's do Cloud9 debugger. Run an application.
Debugging your code.
Where?
Right at the top. Oh, can't do C.
Well, it says C++.
Yeah.
That should probably work. Debugging Basics. Already in here. So based on that, can I change the mode? So it seems to show this at the toolbar at the top. Here, just real quick, if we create a new file that's a CPP file, let's see if it detects it as being something that can run in the debugger. Yeah. So a CPP file automatically gives you access to the debugger. So it looks like we probably could run all of ours as a CPP file and it would probably work fine. Let's do something here real quick.
Is this going to turn into a C++ class?
From our perspective, it won't make a difference. But let's just see if it'll still work. Because I think this guy's just judging it based on the file extension. So we'll just change our client to CPP for a moment. Let's just run it, make sure he still runs. Yeah, he's still... Oh, yeah, no, I didn't like the headers. Oh, because it's not running it through GCC, it's running through G++. All right, well, that ship has sailed. We're not going down that path. So I suppose in the end, no, you can't debug. What's the... so we should be back in business now. We can run that guy listening, run this guy connected, and received. Okay. So let me... All right. So in any case, that was the issue we were running into. Is I was using a error integer value as a file descriptor.
No, you can use breakpoints in the debugger. You just weren't running it right.
Oh, no, if you.
Yeah, you just
Oh,
have to
just
do
let
it
me click
down
it?
here and
Yeah.
run. Yeah, run.
Oh,
it
see, I never saw that there before.
I literally just saw
I
that too.
just did. Yeah,
And
then hit run in the box.
Well, that part shouldn't matter. Okay,
and
yeah.
then there it is.
That's weird.
hit breakpoint.
Oh, I wonder if I have to specifically tell this guy to... I mean, that's the...
Yeah, works.
But it's not letting me step over it.
Yeah.
Can you?
Huh?
That's weird. I had more stuff listed than you did.
Oh yeah, you just press at the top. There should be a little play resume step into.
No, there's buttons there, but they're disconnected for me.
Oh, well,
Your stuff's broken.
All right, so there's my breakpoint.
Do you have a new instance of the server running that it can connect to?
Oh, well. Yeah, it could be dying on that, you're right. All right, servers listening now. We have debug mode turned on, run. There we go, yep, so it stopped. Was it actually giving me the value of error? Oh, here it is. Value is 5. So that was, oh, the number of, yeah, hello, the number of bytes that was received. All right, fair enough. So it looks like we could do some stuff. Well, that will be helpful. Okay, so now we're able to establish a single incoming connection. Now, what we want to do is we want to fake this. So this is probably going to make it difficult for us to just hit the run button. We'll have to do it from a couple of consoles. We want to make it so that our server can receive incoming connections and immediately start listening again for another incoming connection, allowing us to have multiple clients connect at the same time. Make sense? And then what's the server going to do? It's going to build up a list, a collection of connected clients. We'll talk about what that means here in a second. But for right now, let's just get our server listening indefinitely. Did we ever decide how I can get this to turn off where it doesn't show me everybody highlighting my code? Including like, it's just got like people just hanging out over here.
Everyone.
It's like I can't even see the names of functions. just covered up.
Is it not constantly highlighting and unselecting?
Why Sprout?
They were.
Your name's in the way, Evan.
All right, well, whatever. All right, so down here, this is where we were listening. And after we listened, what did we do? We printed something out to the client, so we accepted the incoming connection. So for right now, let's go ahead and get this guy on infinite loop for the moment. So we'll say while true, do some stuff. We'll say listen FD is equal to that. Let me go ahead and we'll put a closing curly brace here. We'll highlight everything in here. Tab it over. All right, so forever it should listen, print out listening, accept a incoming connection. Again, this client FD thing here is actually, hold on, that's weird. That's super weird because I'm sending the message to client FD.
That works.
So if I do man accept, this guy must not return a. Gosh, Hexton, you're always in the way.
Why am I don't
He just parked.
become a part of it.
Connection-based socket stream. It extracts the. Okay, so this guy returns an int. That's fine.
Non-negative file descriptor of the accepted socket.
See, it's weird. Oh, actually, that's not weird. That's exactly what we needed to do for our application here. So, accept would be something you would use on the server side of things, right? Connect would be something you use on the client side of things. Connect doesn't need you to give it a file descriptor, doesn't need to return a file descriptor, rather. It's just activating the socket you send it. On the server side, however, we have kind of a single socket configuration we've built up for this listening server, this listening socket. When we accept an incoming connection, what we really want to do is spawn off a new socket that's the result of that connection based on a copy of our default socket. That way, when we spin back up, we can listen again using the same original socket model. That make sense? So at first, it doesn't seem like it should work that way based on how the other connect call worked, but this guy returns a, see it specifically says the original socket FD is unaffected by this call, so it does not activate it like the connect did on the client side. So that's why this code works. That's why when we send, we're sending to the client FD, so this guy is accurate. So I'm actually going to say int client FD out here. Just creating my variables before our loop. That way we're not recreating variables each time through. So we'll set client FD equal to the file descriptor that's returned from accepting that incoming connection. We'll say client is connected. And we print out the file descriptor. And then we send hello back to them. And this guy ultimately just spits out, I sent the data. So data sent. Hits the closing curly brace here, loops back up. The while loop says go and listen again. All right, so that's what this guy does. So we'll go ahead and run our server here. Oh, hold on. Oh, that's funny. Let's see. I actually kind of hate running it in that. Oh, I have it as false right away. There we go. Old C, it's 1 is true, 0, or non-1 is false. There is no specific true and false without the standard template library. Then you can use capital TRUE and lowercase or capital false, which are actually called macros. All right, so now our server is listening. We're going to go ahead and connect once with our client. So I'll give ourselves a new terminal, so we'll do cd chat client gcc chat client ./a.out. So this guy received a hello. The server should still be cooking. Data was sent. It's listening again. Well, I guess I can connect again from the same place. All right, but the idea is we want to maintain that connection. All right, so we want to have a single client being able to send information back and forth to a server, or at least being able to receive multiple pieces of information to a server. So let's go back over to the client side. All right, so this says we are connected, and this is when we're going to start receiving our response here. So we're going to go ahead and make this be an infinite loop as well. And then we'll indent the stuff inside of it. Oop. Well, whatever, I'll just backspace that. All right, so after we've established a connection, we'll go ahead and give ourselves the close to 2 megabyte or 2 kilobyte buffer for receiving text messages. And then forever, we'll try to receive a message and just spit out the message every single time we receive it. All right, so the client's kind of on call, ready to hear stuff. He's not able to send stuff to the server yet, but he's able to receive stuff from the server indefinitely. Okay, so that way the server will effectively, or the client will effectively block. When he comes back around, this call right here blocks until somebody writes to that. So he'll be sitting there just waiting for the server to finally send him a message. So make sure the server's still listening. He is. Make sure I saved this. I did. We'll do another build. All right, so client has now connected, and he's sitting there on the second, waiting on that, waiting for the server to send something again. Make sense? So I'll go ahead and open up another terminal. We'll establish a second incoming connection, because notice here our server is back to listening. He just hasn't sent another message to the original guy because we didn't tell him to. So we'll move into chat and client, and then we'll do GCC. Well, actually just ./a.out. All right, so this guy has connected and he's blocking. Server sent out another message. We see the hello there, and he's listening again. All right, so now everybody is stuck in a communication channel now. What we want to have happen is we want to have our server broadcast. Let's start off with broadcasting hello to every single connected client every single time a new client connects. Decent starting point. All right. So first of all, in order to do that, we need to remember our connected clients. Okay. So we're going to store a collection of our connected clients. Those guys are file descriptors, just integers. So we're going to need an array of integers. Make sense? Now, in C, because of the nature of the language, we're going to have to, well, unless we decide to write our own linked list for this, which we're not. we're gonna create an integer array and then just keep track of how many dudes are actually connected, effectively giving ourselves a maximum number of guys who are connected at once. Make sense? All right, so let's just say we can have 1,000 simultaneous users in our server. Fair enough? We're not going to probably test it with 1,000 simultaneous users, but we can have 1,000 simultaneous users. So we're going to go back to our server, and after we get into our binding, so this is where we're listening. So right before we start this, we want to go ahead and we want to create a integer array. So we're going to have an integer pointer, connected clients, and this guy is going to be equal to malloc 1,000 times size of int. Realistically, it's going to be times size of let's just do this the way the cool kids would do it. Oh, this is just unusable at the terminal here right now. This is definitely going to hold up well to 1,000 incoming connections.
It's gonna break Cloud9. Whoa. Whoa.
Yeah, see, we've abandoned that socket, so this dude is reading from the socket over and over again.
They're never gonna get it back.
Yeah, that ship has sailed.
Well.
All right. This guy takes in. Oh, yeah, it's just an int. I thought it was like one of those weird types that actually mapped back to an int. All right, so we're going to have our connected clients is going to be a integer pointer, effectively a array, and there is a syntax for arrays in C, but now that we've been used to using the memory allocate stuff, let's just keep with it because it makes our code look cooler. So we'll memory allocate 1,000 integers, enough memory for 1,000 integers. Now we're also going to have to keep track of, because C does not know how to report how many elements are actually in an array, or an array's total length for that matter. So really we should probably do something like this. Int max clients is equal to 1,000. This would then be max clients, and then we'll have and actually let's just call this guy clients. All right, and then this guy should be number of connected clients, and it'll start off as 0. All right, so every single time we have an incoming client that connects, we want to go ahead and add that file descriptor to our list of connected clients. All right, so right here, a client was connected. So we spit out client was connected, and we're going to go ahead and add this client to our array of clients. So we're going to say clients at bucket number of connected clients is equal to, actually let me think about this. Yeah, plus plus exists. Actually, did plus plus exist back then? Yeah, will it compile? Let's find out if it compiles on GCC. Number of connected clients plus plus. Remember, this will boil down to the current value of it and then increment it. So we're going to put clients at bucket 0 the very first time. Client FD. And then number of connected clients will go up by 1. Okay. Then we'll go ahead and the server will send out its message. But right now it's sending its message to just that one client, the client that just connected. Instead, what we want to do is we want to broadcast those messages. So what we're going to do down here is we're going to go ahead and we're going to write a function, void broadcast, and this guy's going to take a char pointer message as well as a integer pointer clients as well as an integer num clients to broadcast the message to all of those guys. So we're going to go ahead and we're going to stop error checking again. Cool kids don't error check. And that's why cool kids spend 2 weeks figuring out this code. That's all Haxton's fault. All right, so we'll have that in there. So we want to go ahead and write a loop that goes through all of our clients. So we'll have for, oh yeah, that was I is equal to 0, I is less than client, I plus plus, we'll find out if that's legit again. Each time through, we're going to do a send. Who are we going to send to? We're going to send to clients at bucket I. Actually, if we want to be really cool kids, we'll say clients plus I times size of int and we would say star that. So this is the same thing as saying clients at bucket I. So this is that whole base address of clients plus I times the size of int offset. So this will boil down to a memory address, and then this says give me the value at that memory address. So again, cool kid C code. So we're going to send to that particular client this message, give it the string length of message. All right. And then let's go ahead and just do a put s sent to client. So we should see that come across some number of times. All right, so broadcast will take in a message it's going to send. It'll take in a list of clients. It'll take in the number of clients that we have there. The loop will go through each one of those clients. And for each one, it's going to send a message over that file descriptor. This message, the length of the message, and then claim it received something. Then down here, we can go ahead and take out this code. And we're going to go ahead and call our broadcast method, or broadcast function. And we're going to pass this guy message. We'll pass him our clients. And we'll pass him our number of connected clients for him to do all of his stuff. All right. And it's going to scream at us, I think, because we haven't prototyped that. So we'll go ahead and just prototype it up here. All right, let's see what we got. All right, so it's listening. Give ourselves another terminal here. So there's our hello. Server sent it to the client, but just one client. New terminal. CD chat client./a.out. The first guy got his second response, but this guy hasn't received anything yet. He's blocking. He's waiting to read that first thing. Did the server say he sent twice? Sent to client, sent to client.
Can you have multiple clients on the same port on the same machine?
Sure.
Yeah, because that port is only used for the initial connection. Because we're handing them off. Each of these clients are their own process. So they open up a connection and then a socket is created as a result of it. So it's like having an open phone call. So these guys are effectively on a conference call. So it's not that we have multiple, that there are multiple guys connecting to the same port. Let's open up one more of these guys. Chat.
Will the first one get it and the second one get it? Not the last one?
Yeah, so he hasn't gotten it, but the first guy,
Getting old.
first guy's receiving everything. Okay, so
So would there be a race condition if two clients connect at the same time?
could be. Yeah. Let's see. D. Let's find out if our cool kid code is actually accurate cool kid code.
So we find out you're a lame kid.
Yeah, I was just thinking the same thing.
When your cool kid code doesn't compile.
Oh, these guys are all going crazy now.
They're getting it now.
Well, regardless, your homework assignment for Wednesday is to allow the client to respond back to the server using Universal I/O. So you don't have to handle the multiple clients connecting, just one client. Server sends the client a message, client's printing out hello now, server now sends a message back to the, or the client sends a message back to the server should then expect a message and spit it out. So showing two-way communication over that socket. All right, I'll put,
Just getting the two-way communication.
yeah, that's it. Yeah, we'll have multiple assignments, but little steps at a time. All right, so let me,
It should take 2 seconds, right? Yeah, it's better. I'm never letting you do this.
Hopefully, the third iteration of this problem works.
Oh yeah, I mean, it works everywhere. Did you change it, or did you change it to be the correct desktop?
Actually, I guess.
No, I would. I followed you. I don't see it. We're using